All right, we are going to work through 2.3 absolute value inequalities. Visual solution to a set. That means more than one, right? Absolute value inequalities. Determine whether each of the integers -5 to 5 is a solution to the given inequalities. If the number is a solution, plot it on the number line. So only if it's a solution. We got to remember what an integer is. It's positive or negative whole numbers. So with this in mind, there's no decimals, no fractions, right? And a solution is any number that makes an equation or inequality true. Okay? So all I'm doing is plugging these things in, right? You notice the absolute values for the input. That makes everything positive. This is -5 is a positive 5, plus 2 is 7. Positive 4 plus 2 is 6, and we can see the pattern 5, 4, 3, 2. And that's our 0 number. So now we're going to go back up. Obviously these stay positive, so absolute value of 1, 1 plus 2 is 3. We can see our number line climbing back up. And this says the solution is any output that is less than 5. So it looks like these numbers, -2 to +2, are less than 5. So I'm going to just kind of bubble those on here. And we have plotted all the solutions to this. When we come over to this guy, we notice it's the exact same thing, right? Except now it's saying greater than. So I can actually fill this in. So we got 7, 6, 5, 4, 3, 2, ooh, back up, 3, 4, 5, 6, 7, except now it's saying, hey, greater than 5. It looks to be these two numbers up here, -5, -4, and we skip all the way through these to 4 and 5 right there. So we can see the grouping's a little different right here, right? When we were less than 5, it was all the ones in the middle. When it was greater than 5, it was all the outside. This looks very similar to a disjunction you and I talked about, or all of us talked about last week. So think about it. State the solutions to absolute value of x equals 5. Well, the solutions to that would have been x equals -3, x equals 3, and then relate to the solutions you found. Well, it looks like positive or -3 were in neither, right? Neither of the solution sets. Neither of the solution sets. Right? Because there was no equal sign on here, right? No equal here, no equal there. Alright. So we're going to come down here and we're going to do something a little different, right? Now it says any real number, right? Any real number. And we're going to see those. So we remember this. It's the same thing, except now we're not talking about integers. So we had the same problems, right? Less than 5, right, would have been, well, up above. Less than 5 was -2, -1. I'm going to go ahead and bubble all these in, but I'm going to stop here. Is 3, right, a solution? Well, I come up here, and 3 actually gives me 5, which isn't exactly 5, but I could go right up to 3 and get a solution. It's like 2.9, 2.9999. So I'm just going to put an open circle around 3, an open circle around -3, and since our solution set is fractional, all real numbers, I can actually bubble in between this. So any real number I plug in, -2.5, right? That would be positive 2.5 plus 2 is 4.5. Any number from here to here would be true. Likewise, any number on the exterior out here would be true. Again, excluding the two equal. So it's these number lines. This would be an or, and this would be the word and, right? I can either be below 5 or above 5. I can either be, but this one I can be both below and above. Anyway, that is page 1. I'm going to take a quick look at page 2. I'm trying to get this up tonight for you guys. And it looks like page 2 is completely different. So I'm stopping right here, and we'll post.